In this problem, we're going to examine Newton's second law and how we balance forces. In our first example, we will look at a box with 4 forces acting on it. In this case, in this example, the summation of the forces, well, sigma means summation, just means you add all the forces up. The summation of the forces equals 0. Now when we add the forces up, we'll do it primarily in the x direction, only x, and then in the y direction, only y. In the x direction, we have 2 forces, 8 and this unknown one. In order for those forces to balance, we must have an equal amount in each direction. So if it's pulling 8 newtons this way, it must be pulling 8 newtons of force this way. Likewise, if we have 10 pulling up, we must have 10 also pulling down. Now when I say force equals 0, the total force equals 0, that we may have an object in motion or we may have an object that is stationary, but the acceleration is 0, meaning it's not moving any faster or slower. In our next problem, we'll first look at the horizontal forces. So we say the summation of forces in x is 0, by which we mean that we have 2 and 8 in the negative direction, and we have 4 in the positive direction, and some unknown quantity, I will call it x, equals 0. If we solve this, we'll see that x equals 6, and we have 6 newtons of force to the right. Likewise, if we take the vertical forces, we can write summation of force in the y direction equals 0. And the forces in particular are 13 up, 10 down, and another unknown force I will call y, this being y right there. So we take our little equation. If we solve for y, we see that y equals 3. We can put 3 right there. So we have 13 up and 10 and 3 going down. 10 plus 3 equals 13 equals 13. The total amount of force going down and the total amount of force going up are equal. So there's no acceleration up or down. Our last example involves a diagonal force. This is a very common situation and important to understand how to deal with it. In this case, we also have summation of force equals 0, but we're going to do it separately in terms of y and x, and separating it into vertical and horizontal components. This is extremely useful. To do this, I'll call this one x, I'll call this one y. For summation of forces in the x direction, we will have the horizontal component of 10 is at 15 degrees, so I will write 10 cosine 15 degrees minus x equals 0. And for y, I can write summation of forces in y equals 10 sine 15 degrees minus y, because y is in the negative direction, equals 0. We can also do this almost as simply if we have the summation of our forces equals an acceleration, mass times acceleration, but that's not in this problem. If we solve these problems right here, these equations, we'll find that x equals 2.6 newtons to the left, and y equals 9.7 newtons of force downward. That way, our total force to the right, 10 cosine 15, equals is counterbalanced by 2.6, and 10 sine 15 from the diagonal force is counterbalanced by the 9.7 downward vertical force. The total force up and down is 0. The total force left and right is 0. That is the meaning of summation of forces equals 0. This plays out identically if we work in 3 dimensions with x, y, and z.